Thanks very much. I just want to clarify, it's not that I don't do anything for Google, it's that I'm not doing this talk in my capacity as a Google employee. I work very hard for Google, we're hiring. So welcome to the prestigious after lunch slot on the program. There's already a couple of people asleep. That's my metric for this session, is how many people I can prevent from falling asleep. But if you need to sleep, I understand. I need to sleep too. Feel free to sleep. There's no judgment. This is a safe space. Having said that, I'm going to talk about building and scaling high-performing technology organizations, which sounds very generic, so I'm going to give you a bit of a framework for thinking about this. This is a diagram I once created of the enterprise. How many people work in a company of less than 10 people? Anyone? Oh, a few people, all right. 10 to 100? Okay, lots of you. 100 to 1,000? Wow, lots of people. 1,000 to 10,000? Another lots of people. 10,000 to 100,000? Okay, getting less now. 100,000 to 1 million? A few people, all right. Anyone over 1 million employees? No one working for Indian Railways or People's Liberation Army? Okay, all right. So, anyone who's worked in a big company, you'll know that there tends to be a division of labor. There's the golf-playing class kind of on the left, and you've got the engineers working on projects, and then you've got infrastructure operations. Martin Fowler is here somewhere. You can check with him. I believe this is valid UML for the big ball of mud you're running in production. And this isn't even too bad. We don't have outsourcing. We don't have separate testing departments or anything like that. We have a machine that goes bing to tell you that everything's working. When we actually want to do something in an enterprise, we use this thing called projects. And the way this works is that after a particularly fine round of golf, some business person comes up with a new idea for a product, and then many months are spent going through budgeting and analysis and requirements gathering and all this kind of thing before some enormous plan lands on some poor project manager's desk. They and their team spend many months, maybe even years, building that thing before tossing it over the wall into IT operations, where it gets wired up. We make sure that it actually works. The team that built that thing, whoops, that went wrong. The team that built that thing then goes and disappears and does something completely different instead. And the thing they built lives forever in production. Who works in an organization of more than 1,000 people that's retired a major service in the last year? Okay, a few of you, well done, excellent. Bonuses all round. And there's many problems with this model, not least the fact that it takes so long to get anything done. And of course, the solution to this problem is agile. And so we send all the engineers on the 2-day, whatever framework du jour is, training program, and then we're all taking orders from management standing up instead of sitting down. And that huge backlog of work we can't ever complete is now prioritized and estimated, and now we're agile, yay! How does the rest of the organization react to the exciting news of the agile transformation? Are they filled with joy and happiness? Not normally the case. So the golf-playing class on the left, the whole point of agile is more collaboration between business and engineering. So now, less golf, more talking to engineers, and the engineers normally are living in the basement, and the carpet's not very nice, and that's kind of awkward. And then the engineers don't want to spend more time talking to the business, because the whole reason you become an engineer is so you don't have to talk to other people. So, awkward all round. And then, if that works, what happens is engineering is now delivering more stuff ever faster into production, and IT operations is like, please stop, please. And engineering's like, what do you mean? We're doing TDD, we have nicely, highly encapsulated, loosely coupled software. IT operations is like, well, that's fabulous. It's a shame it doesn't actually work. And it's important to remember that IT operations has a natural and logical reaction to this problem. And that reaction is to create a barrier, which is called the change management process. And the job of the change management process, of course, is to make sure that nothing ever changes. So maybe you've got a friend who works in an environment like this, and you're wondering, can we do better? And I like to point out that yes, we can do better. So these stats are from Amazon. There's definitely much better stats from Google as well. And these are from 2011. Amazon's deploying every 11.6 seconds into production. On average, 1,079 deployments per hour. On average, 10,000 boxes receiving those deployments, up to 30,000 boxes receiving those deployments. Who's seen this slide before? Okay, some of you, but not all of you. Good. It's important to remember, number one, Amazon is a highly regulated company. They have to, they're publicly traded, so they have to follow Sarbanes-Oxley. They process the occasional credit card transaction, which means they have to follow PCI DSS. So, this is hard for them to do. It took them 4 years to re-architect in order to be able to achieve this, to a service-oriented architecture. And these are aggregate metrics. So this is aggregated across all their production services, of which there are, thousands, I expect. So this is really hard. But what it lets them do, critically, is get much faster feedback on what they're building. And the reason that's important is because kind of the end goal of this, and Mike Roberts is talking later about kind of an experimental approach to product development, and you'll see a lot of people talking about an experimental approach to product development. When you can deploy hypotheses, experiments, and get feedback, what you can do is start not building the stuff that doesn't actually deliver value to your organization. And Ronika Harvey, who built Amazon's experimentation framework and then went to work at Microsoft to build Microsoft's experimentation framework, has lots of data from running experiments for features that they want to build. And his data shows that evaluating those experiments, only about 1/3 were successful at improving the key business metric. And if you extrapolate that, what that means is that 2/3 of the work that we're doing as an industry is delivering zero or negative value to our organization. That's the biggest source of waste, is the stuff that we build that delivers zero or negative value. And if you're not actually testing your ideas before you build them, probably you could be spending 2/3 of your week at the beach and delivering the same value to your customers, if only you knew the 2/3 of those features that you're building that aren't actually delivering value. So, me and my co-founder of DevOps Research and Assessment, Dr. Nicole Forsgren, have been conducting this 6-year now research program into what makes a high-performing organization. So Dr. Nicole Forsgren, she's the principal investigator, and I work with her to do this research. And we've studied all different kinds of organizations of all different sizes. So very large organizations, 10,000 or more employees, is 25% of our of the people we've studied. We've studied all different kinds of industries, including financial services, insurance, healthcare, government, highly regulated organizations. And I want to point out right now that these results generalize. They're generally applicable to all different kinds of organizations of all different sizes, including highly regulated companies. And the first thing we found in our research back in 2014 is that software delivery performance matters. We've been told for years that IT doesn't matter. That's not true. What we find is that firms with high-performing IT were twice as likely to exceed commercial goals such as profitability, market share, and productivity. So your ability to deliver software matters. We found in 2017 and 2018 that actually software delivery performance matters for non-commercial goals such as the quality of your products or services, customer satisfaction, your ability to achieve organization and mission goals, and so forth. So it's important whether you're working in commercial domain or non-commercial for these reasons. The next thing we found was a valid and reliable way to measure performance. So there's many terrible ways to measure performance, like lines of code or velocity and all these other measures that are local and easy to game and bad for comparing people. This is the measure that we used. And what you can see is there's two measures of kind of throughput or tempo, and then two measures of stability. So lead time for changes is when you check a change into version control, how long does it take to get that change out to production? That's lead time for changes. And then deploy frequency is how frequently, obviously, we can release to users. Time to restore service is when you have an incident in production or some kind of outage or service degradation, how long does it take to restore service? And then finally, change fail rate is a kind of a measure of the quality of your release process. When you push a change out, what percentage of the time do you have to remediate? And what we found is this, and if you take one thing away from the next half an hour, it should be this. High performers do better at both. They're not trading off speed against stability. They're not moving faster and breaking things. They're improving speed and improving stability and improving quality. They're getting better at all of those things. So every year we publish a table which shows how these groups perform, the median values of these numbers for these groups. And we find high performers are deploying between once an hour and once a day. Lead time for changes is between once a day and once a week. Time to restore service is less than a day. Change fail rate is really low. If you go to the other end, all those numbers are much worse. And this, last year I should say, 2018, we actually found an elite performing group, which is a subset of the high performing group, where they're doing even better. They're deploying multiple times per day. They can get changes out less than an hour. Time to restore service is less than an hour, and they maintain this low change fail rate. What we found last year is that actually the high-performing group is getting better. So the industry in general, since 2014, we've been increasing the percentage of high performers. So if you're not getting better, if you're staying the same, what that means is you're actually falling behind compared to the rest of the industry. So there is competitive pressure to improve. And this elite performing group is 7% of the total. Last year, we also looked at availability. So we extended our measure of performance to also look at availability in production. We find that teams that are high performers are also much more likely to be in the high-performing group for availability. They do much better at availability as well. So again, these things go together. Stability, throughput, availability. The people who are doing well at all of these things. Obviously, what you want to know is, how do we become a high performer, or how do we become an elite performer? So over the years, we've measured many different capabilities that we hypothesize influence performance. And I'm going to show you a very big diagram, which you probably won't be able to read from the back, but I'm going to break it down into little bits. The key things to bear in mind are this. Software delivery performance up here, that's speed and stability that I talked about just now. Organizational performance, commercial and non-commercial. Software delivery performance impacts those. And then over here, you have this kind of whole cluster. I'm going to try not to walk off the stage at this point. Good. There's this whole cluster of capabilities that impact performance, a bunch of technical practices, kind of continuous delivery and related practices, and then a bunch of management practices and a bunch of product development practices, all of which impact software delivery performance, but also, interestingly, culture. We found a way to measure culture. I'll talk about that towards the end. So we know that implementing these practices impacts culture, and culture impacts performance. We also found that implementing these technical practices and management practices reduce burnout on teams. So we found ways to measure psychometric things like burnout and culture as part of our research, and we find that implementing these practices reduces burnout, reduces deployment pain, and increases quality, measured in terms of the amount of the percentage of time teams spend doing rework, like fixing things. So we measured a whole bunch of stuff, and we showed the relationship between those things. And then finally, on the left, on the far left, is leadership. And we find that what's required to implement these capabilities is transformational leadership, which you can read all about this stuff in this book we published. And there's a website, DevOps-Research, where you can download all the various reports we produced over the years for free. So I'm going to go through these three sets of capabilities and then talk about culture. Continuous delivery, this is my definition. Basically, continuous delivery is about making releases boring. We should be able to do releases at any time of day by pressing a button. It should be a totally routine activity that doesn't create any downtime. Who in this room is still performing deployments in evenings and weekends? Okay, that's about a fifth of you, I would say, like 15, 20%. So that's a sign that something's wrong. That should not be accepted as inevitable. That's an obstacle that needs to be overcome. We've shown in many different organizations over the last 10, 15 years that it's possible to make deployment a routine, boring, everyday process that can be performed at any time, even in highly regulated and very complex organizations. So we want to be able to get any kind of change into production safely, quickly, sustainably. And the critical thing that we're trying to do in continuous delivery is build quality in. This is W. Edwards Deming, one of the people who was a contributor to the total quality movement, and which kind of spawned the lean movement in manufacturing. And he says, cease dependence on mass inspection to achieve quality. Improve the process and build quality into the product in the first place. So what that means in the context of software is that making sure that the software works and has low defects and scales and is secure, that's the job of everyone, including developers, ops people. We all need to work together to achieve these outcomes and build it into the product. It's not something, if the developers don't build secure software that scales, you can't get the magic DevOps fairies to come and wave the DevOps wand and magically make things secure and performant. The developers have got to build that in. So a lot of the practices that impact or that make up continuous delivery are ways to build quality in. Things like continuous integration, making sure that developers are working on a shared trunk or master, that they're pushing changes into a shared trunk or master at least once a day and running, and that triggers a rapid process of building and running tests that gives you feedback in a few minutes to tell you if you did something really dumb, to make sure that what I'm doing isn't going to conflict with what you're doing, and that we don't find out like 5 days later when everyone on the team has written 5 days worth of code and we try and merge and everything doesn't work properly and we have to spend hours or days fixing it. And I'm going to talk about some of these things in a little bit more detail. One thing in particular I want to talk about is architecture. And we find that architecture has a high impact on your ability to achieve continuous delivery. And when people think about architecture, they tend to think of microservices and Kubernetes and Docker, and these are all great technologies. But I think we focus a little too much perhaps sometimes on the tools rather than the outcomes that the tools enable. And so what we found is one of the strongest predictors of continuous delivery among the group we measured was whether they could answer yes to these questions. Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Can my team complete its work without needing fine-grained communication and coordination with people outside the team? Can my team deploy and release its product or service on demand independently of other services the product or service depends on? Can my team do most of its testing on demand without requiring an integrated test environment, which is one where we have to stand up the entire set of services in order to do any testing? And then finally, the kind of continuous delivery piece, can my team perform deployments during normal business hours with negligible downtime? Now, you can do this with mainframes. Equally, you could have spent many months implementing the latest WYSI microservices architecture on Docker and not be able to say yes to these questions. In which case, you wasted all your money. Because it's not about the technology, it's about the outcomes the technology enables. So whenever you're building new architecture or making architectural changes, always consider the outcomes you're trying to achieve and how well you're doing at achieving these outcomes. And what you'll see is that this mixes facts about your organizational architecture, can we work without fine-grained communication and coordination, with technical facts about your architecture, like can we deploy it without having to redeploy like this complex orchestrated mess. And those two things are connected, which is important. Who here is building stuff in the cloud? Okay, lots of you. So one of the things we wanted to look at was practices, like how are people using the cloud? So NIST, which is the US National Institute of Standards and Technology, has this very short paper with the very memorable name, NIST Special Publication 800-145, which is the NIST definition of cloud computing. And they define cloud computing in terms of these 5 characteristics. Number 1, can anybody self-service the resources they need on demand without having to talk to a person or raise a ticket or something like that? And, What I find in my experience is that already lots of so-called cloud implementations fail this test, because what happens is we buy a cloud, but if you want to get anything done, you have to raise a ticket on ServiceNow. Now, ServiceNow, I've got nothing against ServiceNow, just to be clear. But if you have to raise a ticket as a developer to get your cloud thing to do your work, or raise a ticket to get a change to the security group, it's not a cloud. It's just some very expensive virtualization technology that doesn't change the outcomes at all in terms of the development process. Developers have got to be able to self-service the resources they need, self-service deployments, without having to go through this complex bureaucratic process. Broad network access. Everyone should be able to access the cloud resources on any devices they want, across any network they want. Resource pooling means that we don't have to have a single physical hardware device for every virtual device, so hopefully, if you're using the cloud, you're using resource pooling. Rapid elasticity is the illusion of infinite resources, so we can scale up and scale down on demand, and then measured service means we only pay for what we use. So what we find is that overall, only 22% of teams that say they're using the cloud actually meet the definition of cloud as defined by NIST. However, if you're doing it right, you're about 23 times more likely to be in the elite performing group. So it does matter. Cloud actually makes a big difference, but only if you actually are doing it right. You can do it right even in highly regulated environments. I worked for the US federal government until January the 26th, 2016. And one of the things that I worked on was something called cloud.gov, where we built a cloud system that met very complex and onerous compliance regulations that are set in law. And we were able to meet these characteristics and build an on-demand cloud service for the federal government. There's a white paper on the DevOps Research site where we talk about that and the lessons we learned from doing it. So you can do this and make it work in complex, highly regulated domains. We looked at monitoring and observability as well. And as part of this, we defined monitoring and observability, although recently someone tweeted something which I really loved, which is that monitoring is for known knowns. Testing, like automated testing, is for known knowns. Monitoring is for known unknowns, and observability is for unknown unknowns, which I thought was great. Monitoring is testing for things where you define the things that you're going to gather the metrics for, and observability is when things are going wrong, you've got no idea why, and you really need to find out right now what's going on, so you can kind of debug what's happening in production, which is very important for service-oriented or microservices architectures. If you have a comprehensive monitoring and observability solution, you're 1.3 times more likely to be an elite performer. And having this stuff in place positively contributes to software delivery and availability. Over the years, we've looked at lots of different testing practices. So because we're doing science, we test a whole bunch of hypotheses, and some of those hypotheses turn out to not be true. And that's one of the ways you know you're doing science, when you test some things and you find surprising things. If everything you find is a surprise, that's probably a bit of a worry, but at least some things should be a surprise if you're going to be doing science. So we wanted to test all these different hypotheses, and I think the first or second year we did it, we tested all these different things. See if you can guess which of these things turned out not to be the case. Well, I don't have a lot of time, so I'm going to give you the answer pretty quickly. We found that when QAs primarily create and maintain acceptance tests, that has no relationship with software delivery performance. When tests are primarily created and maintained by an outsourced party, that has no impact on software delivery performance either, or no correlation. Interestingly, we found that developers creating on-demand test environments, that's not a thing either, which we really thought would be a thing. We thought, self-service test environments for developers, that should work. It doesn't. Now, because we're gathering data from surveys, we don't know why. So big data is great, but big data doesn't tell you why things are happening. To find out why, you've got to go and ask people, and that's not part of our research design to do that. So we don't know why this is, we just know that it doesn't work. Last year, we also looked at continuous testing, and we find these things in black do positively impact software delivery performance. And in addition, these other things also positively impact software delivery performance, which is curating your test suites to make them better, higher quality in terms of false negatives and false positives, and keeping their cost and complexity under control. Having developers work side by side with testers throughout the software delivery process, not as a separate phase after dev complete or in a separate group. Performing manual test activities like exploratory testing and usability testing throughout the delivery process. Having developers practice TDD by writing unit tests before they write the code that makes the test pass. And getting feedback from your automated tests in less than 10 minutes, both from your workstations and from your CI server. So these practices we found are important and predict software delivery performance. I'm going to switch gears a bit and talk about management practices. There's lots of things that are kind of well known in kind of management, in the lean management community, that we think obviously work. So, for example, effective WIP limits, managing work in process, doing less stuff so that you can get the stuff that you're doing done as quickly as possible, rather than taking on lots and lots of things and never getting anything done, right? We find that on its own, that doesn't predict higher performance, which was weird. But what we found on further analysis is that if you do all of these things on the left together, it does work. To make WIP limits work, you also have to have visual displays to monitor quality and productivity. And you also have to have monitoring and feed the results of monitoring back into your decision-making process. And doing all of these things together does, in fact, increase performance, result in lower levels of team burnout, and improve your organizational culture or your team culture. But you've got to do them together. You can't just do one of the things, because those different things all work together, even though they're separate things. We looked at product management, and again, we found a bunch of different things that are important. Firstly, making sure that you're gathering, broadcasting, and implementing customer feedback as part of your product development process. Working in small batches, taking big ideas and splitting them into small chunks that they can be delivered in less than a week and released frequently. So making sure you take those big batches of work, split them into small chunks that you can deliver and get feedback on. Making sure that teams understand the flow of work and have visibility into the flow of work. Things like using Kanban boards or other visual tools to visualize the flow of work. And then, crucially, making sure that teams have the authority to create and change specifications as part of the development process. Who has a friend who works on a team where you're agile and you have stories, but you're not allowed to change what's in the stories? Anyone have a friend in that situation? Right, so that's not agile. Like, just because you're using storyboards and you're doing stand-ups, that doesn't mean you're doing agile. It's only agile if you get to actually say, well, let's talk about the value we're delivering, and if this is the best way to deliver that value, if we're going to create the maximum outcome with a minimum output, let's talk about how we could do this. If you can't have those conversations, it's not agile. And we find that implementing these practices predicts software delivery performance, and there's kind of a virtuous cycle. Improving your software delivery performance improves your ability to implement these practices as well, and these practices also impact culture and reduce burnout. And implementing these practices also directly impacts organizational performance, which is interesting. So I want to spend a few minutes talking about culture, because culture is really important, and we find that culture actually impacts both software delivery performance and organizational performance. How do you measure culture? There's many different models of culture. And they're all valid within a certain context. Or at least the ones that have been shown to be valid are valid within a certain context. The one that we used is one that comes from a sociologist called Ron Westrom, who's investigating safety outcomes in healthcare and aviation and nuclear power, which are domains where when things go wrong, people die. So high tempo, high consequence environments. And his model divides up organizations according to this typology, whether they're pathological or power-oriented, whether they're bureaucratic or rule-oriented, or whether they're generative or performance-oriented, or as I like to say, mission-oriented. And there's 6 different categories here. Firstly, cooperation. How effectively do we work together with each other? Secondly, how do we deal with people who bring us bad news? Do we shoot people who bring us bad news? Do we ignore people who bring us bad news? Or do we actually train people to bring us bad news so we can act on it quickly while it's still something we can deal with, rather than ignoring it until it becomes a catastrophic problem that's really hard to do anything about? How do we deal with responsibilities? Do we avoid responsibility because we know that if you take on responsibility, you're likely to get fired or punished in some way when things go wrong? Are responsibilities defined narrowly so that when something goes wrong, we know whose fault it is and who to blame? Or do we share risks because we know that we only succeed or fail as a team? How do we deal with bridging between different parts of the organization? Is bridging discouraged, like don't go and talk to the business? Don't go and talk to the customers? Do we tolerate bridging, or do we encourage people to go and work together? Well, we'd love to do this, but the auditors won't let us. Well, maybe we should go and talk to the auditors, because that's like a totally safe and reasonable thing to do. And then two things that are kind of two sides of the same coin. How do we deal with failure, and how do we deal with novelty? So in high-performing organizations, failure leads to inquiry, whereas in pathological organization, failures leads to scapegoating. Basically, people get fired when things go wrong. And in safety-critical organizations, when something goes wrong, you have an investigation. And investigations often end up with something called human error, which is, it's Heidi's fault. Sorry, I don't mean to pick on you particularly. There you are, and I know you. So thank you for your service. And the question you've got to ask is, well, this happened, and it was Heidi's fault, so we're going to fire Heidi. So what happens next? Well, someone else is going to be hired to do Heidi's job. And what you've got to ask is, if the same thing happens again, what's going to happen? Well, probably that person's going to make exactly the same mistakes, and we're going to fire Heidi's replacement, and there's no change, right? Human error should be the start of the investigation process. The interesting question is, why did Heidi do what she did? How could we have got Heidi better information so she could have made better decisions, or given Heidi better tools so that when she did whatever she did, we knew early on that it was going to cause these unanticipated side effects that you always get in complex systems, and prevented whatever happened from turning into a catastrophic failure that had this huge blast radius. So any investigation should lead to system improvements. How can we improve information flow? How can we improve our tool chains? In organizations where failure leads to scapegoating, what happens is no one wants to try anything new, because by definition, something new, innovation, has a higher risk of failure, and we're not going to try it because failure leads to scapegoating. So in order to create organizations where innovation is safe, you first have to create organizations where failure leads to inquiry, where it's accepted as inevitable in complex systems, including complex human systems, and it leads to system improvement rather than finding people and blaming them. Google actually did some other research which confirms what we found. They wanted to find what makes effective teams in Google. So there's this thing called Project Aristotle that you can go and read about. They expected it to be hire Stanford graduates and no developers and fire all the managers. And what they found is that that wasn't it at all. The biggest factor in building effective teams was this concept of psychological safety, which is that team members feel safe to take risks and be vulnerable in front of each other, which is what I'm talking about when I talk about how we deal with failure. It's okay to fail. So we find that two constructs that we created, this construct of identity, being able to answer yes to these questions, and being in a high-performing organization according to Westrom's typology, that corresponds to the same things that Google measured. Just to give you an example of this, there's a company called Etsy, and every year Etsy has a developer conference, and they give out an award to the engineer who caused the biggest production outage in the last year. And if you hit a 404, if you get a page not found on Etsy, it's a picture of a sweater with 3 arms. So the award they give to the developer who causes, or the engineer who causes the biggest outage, is a sweater with 3 arms. And this on stage here is Rin Daniels on the right here. And Rin Daniels is wearing the 3-arm sweater because they caused the biggest outage in the last year. And you can actually go and read Rin's blog post where they talk about what happened and how the team dealt with it. And it was a very complex thing that no one except some kind of, it was almost impossible to predict that the very routine thing that Rin did could have caused the side effects that it did, which caused degraded performance in the website. But when Rin found the problem, they got on IRC and said, listen, something's going wrong here. And Rin says the immediate response from everyone around was to ask, what help do you need? How can we swarm on this problem and fix it? And then they have a culture in Etsy and Google and all these other high-performing places of blameless postmortems, where after you fix the problem, you hold a meeting, you establish a timeline of events, and then you look at contributing factors, and you discuss how you could improve the system to prevent that happening later, and then you go and test whether the things that you did actually were effective. And so organizations like Google and Etsy and Amazon and so forth do regular exercises where they actually deliberately degrade their performance, their production environment, to check if the things they're doing work. So Google, for example, has these disaster recovery testing exercises that they do, and the team in charge of planning these exercises was led for a long time by Kripa Krishnan. And Kripa has a few blog posts where she talks about planning and executing these disaster recovery exercises and the kind of crazy things they did. Like one year they had this whole scenario which was aliens invade Silicon Valley. And as part of this exercise, they actually turned off the fiber connection between Mountain View and the rest of the world. And all kinds of crazy stuff happened. But it was all reversible. And they found all these problems that they then fixed as a result of this disaster recovery testing exercise. And what Kripa says is, for DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. So it's as much about collaboration and culture as it is about the technical pieces as well. And that's critical to everything that I'm talking about today. It's a coming together of technical practices and management practices and leadership and the culture that these things create and the impact of that culture on your organizational performance in measurable terms. Last year, we also looked at practicing retrospectives and blameless postmortems. We found that those impact culture. They also help create a climate for learning where we treat learning as something that we actually invest resources in deliberately, which also in turn impacts culture. We also found that giving teams autonomy is important. Giving teams autonomy helps create trust and helps create a voice where people feel free to speak up about things. And those things in turn impact culture. Autonomy is important in order to enable organizations to work at scale. You've got to create autonomy. People talk a lot about alignment, but autonomy is important too. There's a great talk that's quite old by tech standards now, from Netflix called Freedom and Responsibility at Netflix. This is one of my favorite slides. It talks about creating a highly aligned organization where everyone are working towards the same broadly understood strategic goals, and we're focused on those goals rather than telling people how to do things. But the other piece of that is that teams have to be loosely coupled. We want to reduce cross-functional meetings except for alignment purposes. We want teams to trust each other and not to have to do this kind of very fine-grained coordination. And then we have postmortems. And that kind of reflects one of the things I talked about in my slide where I was talking about architecture. So you can see, again, these architectural outcomes where we don't need fine-grained communication, that's part of enabling teams to work at scale. It kind of ties into the autonomy piece of it as well. You've got to architect your organization for autonomy in order to be able to move fast at scale. So I'm going to end with a little story from Amazon. This is from a blog post that was written in 2006 by Greg Linden. He was working on the Amazon shopping cart on the recommendations engine. And he built this prototype. If you go to a grocery store, at the checkout aisle, there's chocolate. And if you go to the grocery store after school with your kids and you're buying your groceries, your kids are like, oh, I want chocolate. And you're like, no chocolate for you, it's bad for you. And your kids are like, wah, and you're like, okay, have some chocolate, whatever. Maybe you're a bad parent like me. So Greg's idea was we're going to give people recommendations, but they're going to be customized. So if you bought some things and I bought some of the same things, it's going to recommend me the other things you bought that I haven't yet bought. You should buy this as well. So Greg makes a prototype, takes it up to the VP of engineering, VP of product, and shows the VP of product the prototype. And the VP of product says, do not build this. It will distract people away from checking out. So Greg goes back to his desk a little bit sad, takes his prototype, pushes it into production, gathers data from a bunch of A/B tests, and finds out that this is going to actually substantially increase conversion. Goes back to the VP of product, who doesn't in fact fire Greg, but says, well, listen, we better actually build this thing. And that's how that feature at Amazon got built. Who works at an organization where, against the express order of a VP, you could push a change into production? Okay, so it's a non-zero number, but by no means an overwhelming majority. Greg ends his blog like this: I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a summit intern or the CTO, any good idea must be able to seek an objective test, preferably a test that exposes the idea to real customers. Everyone must be able to experiment, learn, and iterate. So, this data comes from 6 years of people filling in surveys. Tomorrow is the last day that the survey for 2019 is open. Please, 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 fill in the survey if you have 30 minutes of your time. I would super appreciate it. That's the URL. You can take a picture of this QR code. Please get all your friends who work at pathological organizations or indeed mission-driven organizations to also take the survey. Thank you so much for your time, and thank you for coming today.
Are you going to do Q&A?
Yeah, let's do
Good.
Q&A.
That was a loaded question. Can we have a timer up here, please, so I know how much Q&A we have time for? That's a challenge that they'll solve while we answer some questions.
Brilliant.
I'll read them out, you answer them. How
Brilliant.
does that sound? Great.
That sounds right.
There are areas where you can deliver software only once a year. How do you measure performance in this case?
Yeah, so this is why we talk about continuous delivery instead of continuous deployment. Continuous delivery means the ability to release software whenever you want, even if you don't actually do it. So if you look at those metrics, you can still measure. Basically, you've got to do the best you can, which is all we can do. So, I'm not going to be able to show them to you, but yes, great. So lead time for changes, how long does it take you to get changes from check into version control to like whatever the closest thing you have is to release to production, like a production-like environment where you're running realistic tests with realistic loads and realistic data sets, and you feel extremely confident that you could actually ship that thing at any time. Deploy frequency, how frequently do you actually deploy to that environment? Time to restore service, again, you can measure that in your production-like environment or whenever things actually get released, and change fail rate, again, in that production-like environment. So get as close as you can, basically. All right.
So can we have the Slido back up?
Yes.
How do you measure burnout?
How do we measure burnout? So there's a professor, Christina Maslach, who works at UC Berkeley. She's a professor at UC Berkeley. So she's been studying burnout for many years. All these questions basically come from research. So Dr. Nicole Forsgren, the principal investigator, she's an academic. We go and get papers and look for theory that has already been researched and that has been peer-reviewed and published. And we get our questions basically from looking at existing published research. So in this case, we got those questions by looking at Christina Maslach's work on burnout and her papers that she's written on it. So that's where we got those questions from.
Okay, I think we'll do one more, Jez, and that one more is going to be, have you found any correlation between time spent on code quality / technical debt and being an elite / high performer?
Correlation between time spent on code quality and technical debt and being an elite or high performer. I don't think so as part of our study. I don't think we've looked at technical debt as part of our research. There are case studies that I know that have looked at this. So there's a case study from HP LaserJet firmware by a guy called Gary Groover. So he wrote a couple of books on this, and he's done talks on it as well, where he talks about measuring the impact of implementing this stuff on those outcomes that you care about. So I would go and look at that. If you go to continuousdelivery.com, there's a section on evidence and case studies, and there's the HP LaserJet case study there that you can read about. But we haven't done it as part of this particular research program.
Awesome. Another big round of applause for Jez, please.
Thank you. Have a great day.